Assalamu alaikum. Hope you are doing well. If you are new to my channel, please subscribe and hit the bell icon.
Hi, so welcome to this Solid Principle series oriented programming playlist, and in this video we are going to learn about this open close principle. So instead of defining this first, let me show you an example. Okay, so let's say I do have a class. So let's say this class is rectangle. Now this rectangle class has two properties. So basically I'm putting long instead of, you can just do double, something like that. Let's generate getter and setter. Now this is a rectangle class. Let's say I do have another class which calculate area calculator. Now I do have this calculate area method. Now in this method we take rectangle as parameter. Now we can just say okay, calculate area, current rectangle dot length and current rectangle dot width. Now this is okay. So far it seems good. Now let's say if we need to add a new different type of shape. So let's say if we need to add triangle. Okay, now in this case the property name is like base let's generate getter and setter. Now this triangle is also another class, and we need to change this area calculator class to adapt that particular changes, right? So now I need to change this name because I cannot do this. Calculate area, and then I cannot just say okay, this is triangle instead of rectangle, this is triangle. You can see that there is no intelligence for this one because this name is same name, so we cannot do that. Okay, it will not compile this particular code. Let's say if I try to compile this code, it's an ambiguous name detected, calculate area, so it should be different name. So now I can say okay, calculate area of rectangle. To change this name, calculate area of triangle, and then I need to say okay, this is base and then current triangle and this is height, right? Now this is okay. Now later on, let's say if I need to add another class, that is circle, not a legal name, so I'll just prefix it with circle, subcircle. Anyway, now again I need to change this area calculator code. I need to copy the same thing, I need to put it here, and I need to just change this calculate area of triangle to circle, right? Now the issue is that I have to modify this method every time a new different type of shape is added, right? This area calculator class, basically it's changing its code or it's modifying its code, like I need to change this name, and if I use that calculate area in different other places, then I have to change those places as well. Now the problem is that it's increased this modification, it will break the code if it's used in some other places which is not changed according to these changes, right? So that's the problem, that if I need to add any new shape class or any new shape, I need to change this code in this particular area calculator, and it's violating this OCP principle, that is open close principle. So this open close principle means that a class should be closed for modification and open for extension. So what does this means? That you cannot change a class code if it's not for bug or if it's not for the criteria changes. Okay, so it shouldn't add any code in this particular class when it's already in production mode, like when it's finished, that okay, this is usable class. Okay, so you shouldn't change anything in this particular class if there is no bug or if your criteria doesn't change. Okay, let's say like this current rectangle, so we are calculating this area with length and width. So let's say if this rectangle class take different parameter to calculate the area, so let's say it takes the diagonal. Okay, then you need to change this area calculator, and that doesn't violate this open closed principle because the criteria change or this area calculation logic get changed, but you are not changing this method name or you are not changing this particular sub procedure name. Okay, if it's a sub procedure, basically you are changing that particular code where this logic get changed, this requirement get changed. Okay, but you are not adding anything in this section or you are not changing this method name or something like that. So that is open close principle. You shouldn't change this particular class module every time something changed. So how can we adapt with this one? Now we can think that okay, we can just say that this current triangle dot base and then current triangle dot height, so we can have this calculate area in those three classes, right? So that's okay. Like let's say I have the same, so let me just copy this. So this rectangle, so I can just say okay, this calculate area of rectangle, so that is public calculate area. I don't need to take any argument because it's inside this rectangle class, and then I can just say okay, this instead of current rectangle, and then this. Okay, now this is okay. Now I can just copy this one to triangle class, as the logic is different because that should be 0.5 asterisk base and then height. Okay, so let me change this one as well. Now I can have this calculate area in different classes. Okay, and then I can just say okay, this calculate area of triangle basically will be that shape, so that is current triangle dot calculate area. So I'm just delegating this calls to that particular class. Now this is also okay, but still you need to add different method in this section. So like if you add a new shape, you need to add a new method in this section, and you are modifying this particular class, and that is violating this open close principle. So this open close principle is saying that it's in simply put, class should be open for extension but closed for modification. In doing so, we stop ourselves from modifying existing code and causing potential new bugs in otherwise happy application. So when we are using this area calculator and we are modifying method name or we are modifying different existing code, it may cause a bug in other parts where this area calculator is being used. Okay, so that's why it's saying that no more modification in this particular class when it's in use in different area. This is necessary because let's say if I use a third party class, okay, so I don't know all the implementation and it will be bad to change those code and those particular method and their implementation. So instead of that, we should extend that. We can override method and then we can use that method instead of third party classes method. So now how can we modify this one to adopt that particular changes? Now you can see that this triangle class has this area and this rectangle class has this area. Now let me insert a new class that will be used as an interface. Okay, so let's say prefix it with I because this is an interface and there is only one function in this interface, that is calculate area, okay, as double, let's say. So this is an interface. Okay, there is no method implementation and there is no other particular property or any method implementation. So this is just a contractual code. Now I just need to implement those things in these classes. Okay, so I can just say implements I set. Now if I select this one Now you can see that this I shape underscore and then calculate area. So again I can just delegate this to the real implementation, that is calculate area. Now let me change this one, so that is structure. Okay, so I'm just delegating this calculation logic. So it's better practice that you should have a different calculate area method, and you just delegate that call in this section. So you can modify in this section, there is no modification needed in this area. Now I can just do the same thing on rectangle class, okay, and that is calculate area. So there is nothing else in this section. Now how to override this particular boilerplate code? So instead of taking this current rectangle as rectangle, what we will do, I'll just say current shape as I shape, okay, and then we are just saying this current shape dot calculate area. Okay, now let me just implement this, implements I shape. Yep, now let me compile this. So this calculate area. Now you don't need to add anything in this section if a new kind of shape is added, because this current shape is type of I shape. So basically any class which implement this I shape is okay to be this particular object. So like this rectangle implements that I shape class, so this rectangle work as a shape object, okay. So this triangle is implement that interface, so this triangle will work as a shape object for this area calculator, okay. Now when I'm going to use this class, let me show you in demo. So I can just specify length, I can just specify width, and then for this area calculator, let's say calculator as area calculator. So let me dim this. New area calculator, and then I can just say calculator dot, so area calculator, this is private, let me make this public. Now calculate area of rectangle, so let me change this name as well. I can just say calculate area of shape, but let's skip this, calculate area, and then I can just pass this rectangle. Okay, let me print this immediate window, Ctrl G to open this immediate window, and now if I run this, you can see this is 200. Okay, now I can just do this same thing with different kind of object. Let's say triangle as triangle, set tri. So I do have a constructor method in this section, so triangle dot create, and I can just pass this base and then height. So it should be shift and then end to select inter part, and Ctrl C, Ctrl V, and instead of rectangle tri. Now if I run this code, now you can see this 100, right, and we don't need to change anything in this area calculator class, right. So like we can just say this for shape circle, so private radius as double. Now you can just implement that, implements I shape calculate area. So basically let me copy this part. So this calculate area, just do this 3.1416 r square, that means this dot radius and this dot radius. Now I can just pass this circle set circle. I don't prefer this kind of naming, to make it short I am using this. Okay, so set circle dot create, and then I can just pass, let's say 10, something like that. Let me copy this. Now if I run this again, now you can see this 200, 100 and then 100. Okay, TRI. Let me run it again. Now you can see that 314.16 for this chart. Now anytime if you need to add any new kind of shape, like let's say I need to add one more shape, that is trapezium, you don't need to change anything in this section. So this class is closed for modification or alteration, but it's open for extension. Now let's focus on this open for extension part. Okay, so let's say this rectangle class. So this is a good example of this open for extension. There is one more good example, that let's say in Chrome browser or any browser you can install extension, right? So yeah, so you can add extension like this image to text, or you can add one more extension, that is Grammarly, to check the grammar. So you are not modifying this Edge browser, but you are just extending that browser using that extension, right? So that's the good example of this extension, like open for extension. Now you can see that this we need to extend this. Okay, so basically let's say we need to have the same calculate area method, but we are going to add some more details in this particular class, or overriding property in this class. So we can extend this class basically in different way, like we can just inherit this one, which is not available in VBA. Sorry to bear bad news. So that's not an option for us, but we can just use composition instead of inheritance, and then extend this particular class property behavior. So I can just use another class, that is extended rectangle. So basically we need to have an instance of rectangle class, and we do this composition in this way. I do have another video on this composition. I'll put the link in that iCard, so just check that out. So now let's say I do have other property like private add error correction to area as let's say long. So let me generate this getter. Now I can have this same interface implementation. Let me copy this extended area class, that is calculate area. So in this section what I will do, this dot rect dot calculate area plus this dot add error correction to area, and then I will just pass this one. Now in this section I can just say dim x rec as extended rectangle, set x rec x new extended rectangle dot rectangle is equals to this rec, and now I can just use this one x rec dot add area let's say 20. Now x rec, now if I run this, and this is 220 because 200 is the rectangle area and this 20 is the error correction. Now you can see that we are just extending property or behavior rectangle class without modifying this class or without altering this class. This is how we need to extend this behavior. So that is for open for extension. So we are not going to change anything in this class, but we are just extending the behavior using either composition or inheritance or interface. So that's it for this video. You know, if you have any suggestion or if you have any opinion about this OCP principle. Thank you for watching. Have a good day.